So welcome everyone. So today what we are going to cover is a logistic regression. However, before I thought we will go into logistic regression, I thought let's quickly refresh some basic analytics concepts. So that's what we are going to cover in the initial few slides, and then we will move to the logistic regression technique. Analytics, what it is, we have already defined. So there is just a screen for the completion of presentation slides, so I'll skip it, but let me concentrate on this slide. What is predictive analytics? We know when we talk about BI means what happened. So when we do business intelligence, reporting and all those things, we are trying to say what has happened. We are doing a post-mortem analysis of past. Now when there is some problem or if something good happens, in that case what we do is we do slightly detailed analysis to understand what happened and why it happened. So that is basically the diagnostic part. And once we know why something has happened, if we try to put it in some model form, some business rule form, some equation format by which we can predict what will happen next, in that case it is basically predictive analytics. Okay. So when we talk about predictive analytics, what we are trying to do is predict what is happening. Okay. Predictive analytics is an area of statistical science which deals with extracting information from data and using it to predict future trends and behavior pattern. This is what is predictive analytics. Why analytics matters, we have also seen this slide, because it validates our gut feeling, it quantifies the impact, and it empowers us to take decision. These are the reasons why analytics matters. We also saw what is supervised and unsupervised learning. Quick refresh. When we have a target information available and with respect to that we are analyzing, it is a supervised learning. If we do not have a target, we simply have data and we have said, okay, do some analysis. From that we do some segmentation, clustering and this kind of analysis. Then it falls under the unsupervised learning. Okay. So basically these are the two main classifications of data mining techniques. We saw example of what is supervised and unsupervised. That example is also known to us. Yeah. So I'm not going to go through these details. Okay. I'm now going to touch upon some examples of supervised learning before we move into logistic, because this is what it is important that we should understand. Example of applications of logistic regression or supervised learning techniques. HR. In HR domain, one of the key challenge is employee attrition. There are employees who attrite. Is it possible by seeing the behavioral pattern of the employees, I can say which employee is likely to tender his resignation? Okay. If that is possible, I can build a predictive model. Okay, there is one application of employee attrition. Telecom. In telecom, customers churn. Now, can I predict a customer who is likely to churn even before he does a MNP, mobile number portability? Even before customer moves from one service provider to another service provider, can I predict whether the customer is likely to churn and move out of my services. That is another application. In retail, again, retail has got a problem of customer loyalty. There are many customers who are not loyal. They buy from one retailer in 1 week and then they go to another retailer second week, and the third week they go back to their old mom and pop store. So when there is a 26th January, there is a discounts and offers, they will go to retailer. When there is a 15th August, they will go to retailer. But normally they will go to mom and pop store and do their transaction. Again, these are not loyal customers. Can I predict which customer is going to be loyal, which is not going to be loyal, which customer who is loyal and now likely to move out? Again, it's a problem of churn. If a customer has churned, can I predict which customer I can get back? So I have a database of churned customers, and frankly speaking, in India today, any retailer, if you go and if you analyze their data, they would say we have got, say, 5 lakh customers or 500,000 customers. If you now analyze that base, you will see that of that 5 lakh base, 80% of the customers would not have come in last 2 to 3 months. If a customer does not go to a retailer for 1 or 2 months consecutively, do you think he's still with that retailer? No. So that is a huge pool that many retailers are having today. So there is an application. Can I see their past transaction data? Using their past transaction data, can I say who is likely or whom we can get back into our system? That is an example of win back. In banking, a huge application of analytics. Okay, so we were at examples of how these are used in various organizations. In banking, banking has a huge demand of these predictive analytics models. Let me take some time to explain applications of analytics in banking. Let us first think of what are the products that a bank sell. Deposit products, current account, savings account, term deposits. Asset products, which means loan products. Mutual fund, home loan, car loan, education loan, personal loan, loan against security, loan against property. So there are various kind of business loan. So there are different types of loan products. Investment products, mutual funds, trading account, investment or insurance products, risk insurance, term insurance, medical insurance, health insurance, endowment, so various kind of insurance. Then there are other services, debit card and credit card. Within debit card and credit card, different types of cards. Okay, so they have got a plethora of products and services that they can market. A customer does not require all of them at a given point of time. For example, a customer who requires a personal loan does not require fixed deposit, because if today I'm in need of a personal loan, does not mean it means that I'm not in need of fixed deposit. At different stages of life, at different life stages of the consumer, there are different needs of products. At a young age, probably we don't need insurance or we are not bothered of insurance. But as we get married and as we have spouse and children, our demand for insurance increases. So there is a life stage element also. There is a behavioral and financial elements also. So you can see that there is a huge number of products, good number of products that a bank has to sell. And a given customer does not require them, all of them at a given point. He requires or she requires at different stages in her life cycle. Okay. So that's why there's huge demand for building various predictive models which will help us find which customer requires which product at that point of time. And as such, we build cross-sell models. Now, what is the word cross-sell? A customer has got one relationship with the bank, say savings account. Based upon savings account behavior, I can say which customer require a investment product, or which customer require a loan product, or which customer may be in need of insurance product. By analyzing the savings data, I can do all of this, and for each product we will have to build a cross-sell model. You can use various techniques. One of the technique is logistic regression. Okay. And when we give loans, on one side I will build a marketing models, because if I'm selling a home loan based upon savings account data, I'm predicting who wants home loan based on savings account data. In parallel, using the same data sets, I also have to assess the riskiness of the customer. So parallelly, you require risk models for home loan, personal loan, car loan, education loan, and so forth. So this is the application. Insurance. In insurance, one of the major challenge which many insurance companies face is the mis-selling element. Many people become agents, and in the initial years they have to do n number of policies. There are target that insurance agent has to do some 12 policies in a year, which means at least one policy every month. If he does not do 12 policies in a year, in that case what happens is his insurance commission for the subsequent year on those policies he does not get. To ensure that he gets the insurance commission for all the subsequent years, he has to ensure that many of these policies keep renewing, and every year he keeps maintaining his target of new customer acquisition. So he is bothered of new customer acquisition target every month, every year. In pursuit of that, if his target is not achieved, what does he do? He resorts to mis-selling insurance. He resorts to selling insurance to his families and friends, a small token insurance, saying that please take it this year, do not pay the next year. If a person who has taken an insurance and he does not renew the insurance next year, that is called policy lapse. Policy lapsation is a major challenge. Can I find from my data what kind of policy the customer has taken, which agent has sold, what is the insurance amount, what is the payment frequency, what is the insured amount, and so forth? Can I predict which policy will lapse and which policy will not lapse? It is quite possible. So there we require a model to predict lapsation. So depending upon which event we are trying to build model for, we may use a appropriate terminology like attrition rate, churn rate, win back rate, response rate, lapsation rate, as the case may be. So whenever I use the word, generic word I use is target rate. When I use a word target rate, if it is a model being built for attrition, it means attrition rate. If I use the word target rate and if the model is for cross-selling, which means I am trying to predict who is going to respond to my offer, target rate means response rate. If I am trying to predict lapsation, target rate means lapsation rate. Okay, according to the scenario, we have to interpret the meaning of target rate. Now, this is the applications. Let's see some terminologies. If you recollect, I had shown in one of the slides saying CRISP DM. CRISP DM stands for Cross Industry Standard Process for Data Mining. and we build predictive models. The first phase is business understanding. So when you do a business understanding, the first thing what the business user will give you a business objective for which you are building a model. Now what is a typical statement a business objectives may look like? Typical statement on a business objective may be, I want to reduce lapsation of insurance policies. I want to increase my customer acquisition. I want to cross-sell X product to my Y customers. So there are various kind of business objectives, and these business objectives you can typically put it under the head acquisition, activation. Activation, I have not given an example of activation. Let me give an example. And that is not too common now, at least in credit cards. But what was happening is when the credit cards were newly launched, many banks wanted to start giving credit cards. As a result, many customers today have, as a result, many customers today have 2 to 3 credit cards in their pocket. All of you use all the 2 or 3? Probably not. Only one of them is used. And rest of them remains in pocket or it goes in our wardrobe. It does not even come out of wardrobe. Which means the credit card company who gave the card, he has given a card and that card is sitting idle in your wardrobe. So they have to do something to get you activated. And to get you activated, what they will do? They will send you some offers. For myself, I knew I had a couple of cards and one of the banks sold me a card. I said, okay, take it. So I took the card. And when I took the card, I knew I will not activate, and I intentionally did not activate. Because being in analytics, I knew they will end up giving me offer. So the first offer they gave me, if you use the card at a fuel station, your initial 200 rupees will be waived off. So I went, took my two-wheeler, used the card, said fill the tank of rupees 200, swiped the card, and that 200 rupees got waived off. I did not have to pay. So that kind of offers they give. The benefit to the bank who gave the offer is my card at least came out of my wardrobe and got a place in wallet. Now once it is in a wallet, probably the next step is you may end up using that. So what happens is, to make a consumer use a particular product or service, first you have to get him activated. If you know today, the Geo thing, if we would have not got the service free for 3 months or 6 months, many of the consumers would not have gone ahead and taken the subscription. So for 3 or 6 months, we have got the subscription of Reliance Jio. Once you have that router or the SIM, you are now going to activate also, even if it becomes paid, because you feel that it's a small token amount that he is asking vis-a-vis many other service players. So what he has done, successfully achieved, he's been able to successfully activate many people, and that's the first challenge. Acquiring someone and activating is the most important challenge. Once you are activated, now you can slowly and gradually upsell or cross-sell. Are you getting? Once you upsell and cross-sell, probably there may be some deficiency in services because of which customers will attrite. If those customers who are likely to attrite, you will have to retain them. And for that you require attrition models. Once you are able to retain, naturally things will keep growing then. So this is what the business objectives are, and in each of these business objectives, analytics play a role somehow or other. Okay. For activation, we have activation models. Now once this is the business objective, the next element is convert that objective into a modeling objective. Now what is a modeling objective? Let me tell, say retain. Let me take an example of retain basically, and let me take example from telecom. A business user says that I want to reduce churn. Obviously he is making a statement that he wants to reduce churn, but what is churn? Churn means customer moving out of your service. What services a telecom service provider provide? A telecom service provider provides a service of data, voice, SMS. Churn can mean, assume for the time being, assume all these things are paid services, which means all of them gives revenue. Today many voice is becoming free, but assume for the time being we are still in a scenario where all of these are paid services. If a customer was earlier using data, voice, SMS, all the three functionality, and today all of a sudden he stopped using data services, but he's still using voice, is that customer churned? The customer is churned, partially churned. The customer is churned partially, yes, because your data services income is stopped. Churn, that's what the importance is. When a business objective is given, you have to now classify it into modeling objective. And the moment you are converting a business objective to a modeling objective, you have to be now very pinpointed. What is the definition of churn? Okay, you have to be very pinpoint of what is the definition of churn. In that case, whether the churn is full churn, partial churn. Churn again can mean I have not moved out of your services, but I have stopped using your services. For example, in prepaid, I make a payment of 100 and take the telecom subscription, and now I'm not using any of your services. That number is still live with me. I'm not using it. That 100 rupees is still with me. For 3-6 months I don't use it. Do as a user, don't I need telecom services? I need it, but I'm not using what I paid in prepaid, which means I'm still carrying that number as an emergency number only, but I'm now using someone else's number, some other service provider, which means I have churned. So churn can also mean absence of usage. Absence of usage completely, absence of usage partially, because both of them leads to drop in ARPU, average revenue per user. And that's how you may have to then define churn, which means the moment you get a business problem statement, the first step is convert the business problem statement into a modeling problem statement. And when you convert a modeling statement, you have to be very clear how do you define churn. Okay, the churn can also be defined as drop in revenue by 80%. I can define churn that way also. So modeling objective is to convert the business objective into a mathematical form. If you are able to convert it into a mathematical form, your model objective definition is done. That is the first and foremost step we have to do. Okay? And once you have done that, you will know what is your activation rate, or what is your churn rate, or what is your response rate that your baseline is. Okay, that becomes your baseline. Is this clear, Shriram, Ritika, Parul? Yeah, Shriram?
Yes, sir.
Okay. So let's move to the next step. Target. Now when you build these predictive models, you require something called target. The phenomena or the event being analyzed is called target. So if taking the churn example forward, if I say zero usage of data services by a customer in the next month is churned customer. So what I'll start with a pool of customers who are all users of my data services in the month of say January. Okay. Now I'll see the behavior of these customers in the month of February. And I'm now defining churn as zero usage of data services. So all the customers who do not use data in the month of February, they will be termed as churned customers, and of the remaining who have used it, they will be marked as non-churned. So the cohort, January cohort, where all were users, I'm seeing them in February. In February, if they are used, I'm saying not churned. If they have not used data services, I'm saying churn. And this is how I get my churn rate. Number of churned divided by total base with which I'm starting. That is my churn rate. And that becomes my target. Okay. So in modeling, the phenomena that we are trying to predict, in this case churn, that phenomena is called the target, and corresponding to that phenomena we identify the target rate. Okay. Possible outcomes of the target are positive, which means the event happens, negative, which means the event does not happen. Sometimes you may have certain cases where you don't know whether you should put them as target 1 or target 0. Let me give an example in this same thing. I said zero usage of data services. Now if you find there are good number of customers who has used data services 5 KB, 10 KB, 12 KB, 50 KB, where will these customers go? No, because what our definition was 0 KB, 0 usage, but they have used 5 KB, they have used 10 KB, they have used 1 MB, they have used 2 MB. What you are rightly saying, I've got Govardhan here, he's saying that that usage of 1 MB, 2 MB, insignificant usage could have been an unintentional usage. Now here this unintentional, you don't know as a modeler which customer's usage was unintentional and which customer's usage was intentional. So in that case, what you may say is there is a gray area. This gray zone, you may not be sure whether you should call them as churned, or you may not be sure whether you should be calling them as not churned. In that case, if you are not confident how to classify, many a times that segment we remove out as indeterminate, saying that we are not able to rightly classify them as 0 or 1. So we'll mark them as indeterminate. Indeterminate observations are not considered for model development. Is this concept clear? Shriram, Ritika, Parul? Yeah, couple
Yes,
of yes. Thank you. Okay, let's move forward. Now in this, target is called as the dependent variable. Target is, often we use the word dependent variable. Okay. Now let us see what if target is my dependent variable. The set of variables which will help me predict who is going to churn and who is not going to churn are the independent variables. Independent variables are basically the behavioral variables of the consumer and the demographic variables of the consumer. Let us take this example forward. I said I have all the consumers of the month of January, and in February I am seeing who did not use and who used. Now from which month I can get the independent variables, or from which month I can get attributes of consumer to predict the February behavior. Which month's data can be used? Can I use February month data for predicting February behavior? I cannot use February month's data for predicting February month's behavior. I have to use January month's behavior. Can I use December month behavior? I can use December month. I can use November. So anything which is before the time we are trying to make prediction, that data can be used to create our behavioral variables. And these behavioral variables and these demographics variables that we have before the event occurs, or before the time for which we are trying to make prediction, those variables are called independent variables. A nice diagrammatic I got. This is what shows how light affects the plant growth. Growth of plant is dependent or independent? Dependent. And it is sunlight is independent. Okay, I hope this difference between dependent and independent is clear. Yeah.
One question. Like, if this is an example, like, what about forecasting? Forecasting of nature.
Forecasting of nature. Okay, there is a question which is asked is, what about forecasting of nature? Let us take a nature phenomena which is cyclone. Some 5 or 6 years back there was a cyclone in Hudud cyclone in Vizag. Weather department was able to forecast it. How did weather department forecast that cyclone? See, cyclone happens mainly, one main reason is pressure difference. There is a low pressure in one area and there is a high pressure in other area. And if there is a very high difference in pressures, the wind blows from high pressure to low pressure. Yeah. So if that pressure parameter across different geographies, latitude, longitude is available, can you predict the direction in which wind is going to flow? Yes. So that becomes your input parameters. Are you getting? So similar such events would have happened in the past. When such events happened in the past, because the Met department is capturing these informations regularly, do they have all the information? When a particular cyclone occur, what was the pressure difference which caused the wind to blow? And this pressure difference caused the wind to blow at this much speed, right? So using the past historical data which is available, and when a particular event occurred, they use that information and build the models. That is the example. Yeah. So this was a question which was asked by a person in the classroom. So I'm just addressing that. Okay. Independent variables. The definition is simple. The variable which is experimented in order to observe its effect on the dependent variable. The variable which is experimented in order to observe its effect on the dependent variable. Now don't take the word experimented in a literal sense. So here what it means is, when I am taking this telecom example, And using the telecom example, when I said January data and February is the prediction. Now when I use the word experimented, what it means is, if I have got people who churned in February, I have got a hypothesis that the customers who used less data services in January month are likely to attrite or churn in February as compared to customers who made a high data usage. Okay. Now this hypothesis is giving me a variable which is data usage in the month of January. And now I'm going to analyze this variable with respect to target. And that is what I'm doing, experimentation. Here experimentation does not mean a chemical process where we are going to experiment. Here we are going to do a computer analysis, hypothesis testing to see how this variable is impacting the target. Okay. This way, independent variables in statistics we also call, quite often we use the word predictor variable also. Okay. So from this we now come to the next element, which is hypothesis. So basically when we are building a model, we have to create many hypotheses why a particular event occurred or why a particular event did not occur, which means why some customers churned and why some customers did not churn. So we have to create hypothesis. When we define or when we create a hypothesis, some of the important things that we should take care. While defining a hypothesis, we should ensure explain what you expect to happen. So when I made the definition, customers who had low data usage are likely to attrite vis-a-vis customers who had high data usage. So I am clearly defining, I am expecting more churners coming from low data usage segment vis-a-vis high data usage segment. Is that point clear? To be clear and understandable, is my hypothesis clear? Yes. Can I test the hypothesis? I can test the hypothesis. Can it be measured? I can measure it. Does it contain an independent and dependent variable? It contains an independent and dependent variable. So my hypothesis is complete. Okay. So these are the things we have to take care when we define hypothesis. Now comes the modeling base. What did I start with? I said the entire set of customers who made usage of data services in January. I am seeing their behavior in February. So what is my modeling base? The customers who used in January, that becomes my modeling base. All the customers who use data services in January becomes my modeling base. This base, I'll have lots of attributes of these customers with me. Those are independent variables which we would have created based upon our hypothesis statements. This base is now my model base. When I have this data set to model, what I should be doing is I should split this data into 3 data sets. One is called a development sample, second is called a validation sample, a third is called a holdout sample. On a development sample, we will build the model. We will cross-check the model using a validation sample. Finally, we will test the efficiency of the model on an unseen data set, which we call a holdout sample. So on development, the model is built. So typically when we build a logistic regression kind of thing, what will happen is we'll take 50% of the sample from modeling base, run the logistic regression. When logistic regression is run, some variables will come insignificant. The insignificant variables will get dropped off. We'll see how it all those happens, but for the now, at a high level, understand that some variables will come insignificant, those variables will get dropped off, some variables will come significant, and those variables will be part of the model. Now the variables which have come part of the model, what I'm going to do is I'll take only those variables and I'm now going to take a validation sample. I'll run the logistic regression again on that data. When I run the logistic regression again, for each of the variables I'll get significance and non-significance. If a variable is not significant, what will happen? That variable will get dropped off. That is one possibility. If that does not happen, then all variables will be part of the model, and again beta estimates will be there. We'll compare the beta estimates of development and validation. If it is in line, they are more or less close to each other, the model is stable. And finally we'll check on the holdout. All these processes we will do in a logistic regression as we build the model. But at a high level, this is the concept. A modeling base is divided into three bases: a development base, a validation base, a holdout base. Okay. Now let's understand one more terminology, which is called window definition. Just 1 minute. What is difference in validation and holdout and test sample? Okay. See, many of people, we use the terminology training and testing data set. Training is the data set on which we build the model. When I have a development sample and when I have a validation sample, I train my model on the development sample. Once I got the model, the beta, the variables which are significant, those variables I'll again pass through the regression process, but on the validation sample. What may happen? The variables which came significant in development, some variable may not come significant in validation. If say a particular variable x1 is not significant in validation, but it came significant in development, what am I going to do? I am going to do some tweaking of x1, or I'm going to drop x1 from the development model also. So I've got two options. I tweak x1 such that after tweaking it comes in development as well as in validation. Or if I, after lots of attempts of tweaking x1, how those transformations are there done we will see later, but for now assume there are transformations that we do. After doing lots of transformations of x1, it keeps coming in development, but it keeps coming insignificant in validation. The only step that I can now do is drop x1 from the final model and create a final model which is not having x1. So what happens is, no, x1 variable will not be considered as part of the model. So what will happen is, a development gave me a model, validation said what you developed is not okay, and because of that I tweaked the development again. If the new output of development, I again try on the validation, and if validation again says that it is not okay, I again keep tweaking. What is happening in this process? The final model, we are fitting the final model such that it holds on the development and it holds on the validation also. And it has to hold on development and validation because you are constantly tweaking the development by taking inference from the validation. And the final model that you're passing is a model which holds on development and validation. Is that the way you do testing? You have to test something, a model, on something which it has not seen. and that unseen data is holdout. Because in this entire process of back and forth between development and validation, holdout did not come into picture. Now you take that model, apply it on the holdout, and see whether a model is giving you a good output, good model performance measure, which is in line with your business objectives, which you can use to cross-sell, upsell, retain, churn, whatever is your business objective. If that model is working on a holdout and giving results which is in line with your expectation, you say the model is okay. And as such, development and validation I would put in a training data set. Holdout I will put it in a testing data set. However, quite often you will also come across things where people will say development is my training set, validation is my testing set. When you only have development and validation, probably that will be a right definition, but I follow development and validation is training set, holdout is my testing set. Okay? Parul, is the question answered?
Whatever the tweaking has to be done, it has to be done with validation and development.
Yeah, so if we divide the data as 70-30, training is 70% and testing is 30%. Okay?
Well, just a question now. When you
Yeah.
say tweaking,
Yeah.
tweaking a variable means you mean to say that it's about prediction, right?
See, okay, tweaking. Let me tell you what tweaking means. See, if I have got a variable which is say age. Age as a continuous variable, 20, and I've got range of age as 21 to 58. When I bring age as a continuous variable, age is not coming continuous variable in the model. As a result, what I will have to do is I have to probably bucket the age variables. If I bucket the age variables, in that case I may create slabs saying 21 to 30, 30 to 40, 40 to 50 and greater than 50. Now this bucket variable is coming in the model and is stable. In development sample, when I bucket, it is coming in the model. Now the same buckets when I apply in the validation sample, probably it is not coming. It is possible that validation sample, the 21 to 30, 30 to 40, 40 to 50, greater than 50, that buckets may not give the similar behavior as you saw in a development sample. Scenarios can possible because both are random samples. From the modeling base, both are random samples. And in one of them it is working, in other it is not working. In that case, what you may do? Probably you may see that it should be 21 to 30, 30 to 40 and greater than 40. Rather than having 40 to 50 and greater than 50, probably the third bucket should have been greater than 40. Now you retweak it and create 3 slabs into 4 instead of 4. Now when you create these 3 slabs, you run the development, the variable comes, and now when you run it on validation, again it comes. In that case, what it means is earlier you tried 4 buckets, it was not holding in validation. Now you are trying 3 buckets, it is holding in validation. This is an example of variable transformation where you have converted a continuous variable into bucket. Other transformations are log transformation, square transformation, exponential transformation, cube transformation, converting the variable as a ratio, basically x, and derived x is 1 by x. So various kind of transformation depending upon the trends we may have to do. Yes, Shriram? I'm just unmuting you. Yeah, Shriram, I unmute you now.
Yes, yeah, okay.
Yeah. Okay. Just
My understanding,
yeah.
my understanding, the using the existing whatever the data that we have, we create a model which says this is the behavior, and then to predict it, we can say that this can be these are all the variables that might affect
See
the future,
that
right?
that we do in the model development, all the variable transformation steps. All the variable transformation steps we do during the model development stage. Once the model is built, what was the last transformation, which was the transformed variables that came in the model, those variables only are considered. Whichever form in which the variable came in the model, that form is only considered at the prediction stage.
Okay.
Okay.
For example, if we take on example of a retail or something,
Yeah.
behavior of the purchase or something like that in a
Sure.
particular period of time.
Yeah.
So we have a lot of variables, right?
Yeah.
Which affect. Uh, so we analyze that, we build a model which says these are all the variables, right?
Yeah.
And then for the future, we can predict with a particular variable set. Are we tweaking anything? Like when you say tweaking, I'm not getting the point.
See, tweaking means variable transformation. Like I had age variable which was continuous. Okay, but continuous is not coming in the model. I'll explain. Let me do one thing. Why that may not come. Let me create a small graph here. Just kindly mute yourself, no, because there's some noise also. Say this is my age variable, and this is say 21 is minimum, and 58 is maximum. And now I am trying to see churn. I am trying to see churn rate. Now the trend that I see is this kind of a trend. This is the kind of a trend I see. What is the trend you see in churn? As age increases, churn rate in higher age customers is higher. This is the trend. But in this segment, in this age bucket, is the churn not same? So far the churn is same. Then there is slight increase, and then again it is flat. So this may be a second segment. Then from here to here there is a continuous increase, and then again there is a flatness. And then, so can I say that this is one bucket, this may be a second bucket. Here I may have to create 3 and 4, 2 buckets probably. I can say this is fifth and this is sixth, because it's not a continuous increase, it's a step increase. When I see this kind of a step increase, I cannot bring age as a continuous variable, because age as a continuous variable may, if I bring it as a continuous variable, as a relationship between age and churn rate, it will start predicting things like this. And what will happen, this plateau, it is going to ignore these flats. These flatness, it is going to ignore. In that case, you have to do slabbing. You have to do bucketing. And this is called transformation. Now, when I create a bucket, a continuous is transformed to a bucket. This is called tweaking or transformation. Now, why I use the word tweaking? Probably when I see the development data, this is the trend. But when I see the validation data, probably in a validation data, the trend might be after this, where you are getting this spike, sudden spike, probably this sudden spike would not have been such a jump. It would have been something like this and then something like this. It is possible because these are samples drawn. One sample may show slightly different behavior than the other sample, but rest of the trend is what is there in development is similar to the validation. In that case, from development data, you would want to create 6 buckets, but after looking at the validation data, you may want to create only 5 buckets because that would hold on both development and validation. Okay, so here you may have to merge 5 and 6, and that's is what I was calling tweaking. Now you are making a small adjustment in the bucket definitions. And this as a model development process we keep doing in the background. When we are building a model, this is a step that we keep doing. I hope this is clear now. Yeah? Okay.
One more thing, this
Yeah.
modeling base is derived from the market data, right?
No. Modeling base need not necessarily be derived from market data. I'll explain that now. I'm coming to that slide. Okay. Now, how do you define the modeling base? Let us take this example again, the churn example. I want to predict customers who are going to churn in the month of February. And I'm using all my customers who are acting and who are using the services in the month of January. So my customer base of January becomes a modeling base. Some of these customers may have a behavior with me for some time in the past also, because all of them might not be acquired in the month of January only. Some would have acquired 1 year back, some would have acquired 6 months back, some would have been acquired say 2 years, 3 years back. Now for those customers, what we are going to do is we will decide a certain time period from which we want to create their behavioral attributes. Typically when it comes to marketing kind of problem statement, churn is part of marketing. Typically when it comes to a marketing kind of a behavioral problem, prediction problem, we tend to use recent 3 months behavior or at max 6 months of behavior. So if I am taking all customers which are in January and till January end, I'll take January, December, November. If I want to go only with 3 months, or if I want to go with a 6 month, then I'll go from July to January. Yeah. So that time period becomes my observation window. In that time period, what was the behavior of the customer? Now, what is the behavioral variables? Behavioral variables will be total billing amount per month. Can I compute billing amount per month for this customer? Total data usage per month. Can I create? Total number of outbound calls. How many calls the customer did outbound? Total number of inbound calls. Total outbound calls divided by inbound calls. Divide. I can create. No, variable is variable. Can I create mathematically? Can I create?
Yes.
I can create. Total data usage. Total revenue from data usage divided by total data usage, which means per KB what is the money he is paying. Some customers will pay high, some customers will pay low. Yeah. So these are the variables which I'll now create from the observation period. These variables are your independent variables which will go in the model as a independent variables, in the regression process as a independent variables, and it will be analyzed with respect to your target variable. When it is analyzed with respect to target variable, some variables will come significant, some variables will not come significant. Variables which are not significant, the modeling process will drop them. The variables which come significant, the modeling process will retain them. Okay, so here we have the definition of observation window and prediction window. The window in which the behavior of the customer is analyzed, which means this is the time period from where I'm going to create the behavioral attributes. And prediction window is basically the period for which the customer's behavior is predicted. Now the question is, if I am going to predict the behavior of the customer, then how do I know who is 1 and who is 0? How are we setting the value? See, now my question is the period for which I am going to predict the behavior, then how do I have 1 and 0?
Like in the previous slide, as you said, like if the customer data usage is low, so we are setting it to a 0. As in like he is likely to churn.
See, okay. Now this question is very important. If you are able to understand this, then half the analytics is done. All of you please pay attention. No. When I am building the model, I am going to build the model based on data which is available with me. Okay? All historical data is available. All historical data is available with me. So what I'm going to do, I'm going to take past. I am today in the month of March. I am in the month of March. I have Feb data. I have Jan data. I have whole of 2016 data, whole of 2015 data as a telecom company. Do I have that? Okay. I have all the data with me. Now I know churn is a problem in my company, and each month I'm losing many customers. If I am just doing that reporting, this month we lost 5% of the customers, this month we lost 4% of the customers. We are just doing reporting, right? Now what I am going to say is, hey, can we build a model by which I can predict who is going to churn before he churns? Now to build a model, what I require is simulation. I require some scenario which I can analyze. Not simulation, I require some scenario which I can analyze, real life. So what I will say, hey, I know all the customers who churned in February. Let me take February month as a prediction month. Let me take February month as prediction month. Now all customers who churned in February, I mark them as 1. All customers who did not churn in February, I mark them as 0. Now I want to predict these 1s and 0s with respect to their past behavior. So I'll take December, January, December, November. Assume 3 months I'm taking. I'll see November, December, January behavior and mark and analyze with respect to 1 and 0. I build a model. Now I want to predict customers who are going to churn in the month of March. Can I predict the customers who are going to churn in the month of March? How?
we took a sample of Feb, who already churned in Feb, right?
Mm,
And who did not churn in Feb. So we set the value as 0.
no. Now when I have to predict who is going to churn in month of March, when the February scenario was there, I had all correct actual information. Who churned, who did not churn. I made them as target. I used October, November, December. No, sorry, November, December, January as observation window, built the model. From November, December, January, I took behavioral variables. The behavioral variables which I created based on November, December and January, can I create similar behavioral variables from December, January, Feb data? I can create the behavioral variables from December, January, Feb data. Now, when I got a model, I got some rules or equation. And that rules was saying that from who is going to be 1 and who is going to be 0. Those rules or those equation now I apply on December, January, February data. And when I apply those rules, is it not going to say me who is going to be 1 and who is going to be 0? This time around, this 1 or 0 which the model is saying is actually a prediction. When I'm developing, I'm taking actual data. I'm creating a scenario where I want to predict attrition for February with respect to October, November, December, January data. Now I build the model. The objective of building a model is to get rules or the equation. Once you have the rule or the equation, can I now plug into it numbers of December, January, February and estimate what will be the behavior in March?
Yes.
Now the prediction for March is a prediction.
Yes.
This is how the models are used. Yeah? Is there any question on this? Is there any question on it? Let us try to see this. I am trying to predict churn for February. Assume 5% of the customers in February have churned. And I observe a relationship. For the time being, let's assume single variable relationship is this. This is data usage in month of January. And I see, and everyone is having data usage. Okay. In January, all of them are data usage. I see this trend is something like this. So here, whether, sorry, this trend is not like this. Say this trend is something like this. Okay, where this is high data usage, this is low data usage, and this represents average line. This average line is at 5%. Okay, this average line is 5%, and now here I've got say this one is 1% churn. In very high data usage there is 1% churn, and here it is say 15% churn, which is in very low usage. This axis is your churn rate, and this data usage is for Jan. I know who churned in Feb. I know who did not churn in Feb. This information is available. I can I bucket all of these customers based upon their data usage in January? I can bucket all of them. So I probably have this kind of a trend. These are low data usage bucket. This is moderately low. This is moderate data usage. This is high data usage. This is very high data usage, and this is very high data. These are kind of buckets. From Jan low data usage, I know 15% customers churned. And what is my modeling base? All consumers, all data users in month of Jan. Now this is insight I got when I related Jan data with respect to Feb. Now I want to predict. Now Feb month is done. I have got data till Feb 2017. And we are just in the beginning of March. I want to predict who are going to churn in the month of March. Can you predict? Can you predict? If yes, what is your prediction going to be? So what you are going to do is, now you are going to take all data users of the February month, not Jan, because the model, when you build between Jan and Feb, the model used Jan behavior to predict Feb. Now if you are wanting to predict March, you cannot use Jan. You can use Feb, because it has to be like to like. For Feb, if I use Jan, then for March I can use Feb, not Jan. Okay, now if I want to predict the behavior for March, I'm going to create the same attribute, which is data usage in the previous month. Now the previous month of March is February. I'm going to create the variable. I'm going to create them into segments: low, very low, low, moderate, high, very high, ultra high. The customers who fall into very low, can I say 15% of them is going to churn? Right? The customers who are in ultra high usage, can I say only 1% of them is going to churn? If I can build this as a single variable model, can I now expand this concept to multiple variable model? And when I can expand this to a multivariable model, the point remains the same. If I am using a certain time period of data as an observation window, and based on that I am predicting, okay, based on that I am predicting, in that case I can use the same observation window for subsequent months. I can use the similar observation window for subsequent months and make prediction. So if February was predicted based on January and that trend is proven, development, validation, holdout of model is done, and I'm confident that similar trends I will get in future also. I can then use February behavior to predict March. Once I get March data, I can use March data to predict April. Once I get April data, I can use April to predict May. That is what is a model. That is what a model is. You take available data. From available data, you create observation window, prediction window. When that data is available, you know who are actual ones and who are not actual ones. And you build model on what is real scenario. Now you apply it on continuously on an ongoing business scenario and make a estimate prediction of who is going to be 1 and 0.
So like ultimately you are going to find out like who's going to churn and not. Okay. But what is the point of building a model? You have to apply some relation to it now, so that person doesn't get churned.
Okay. Now the question is, what is the point of building this model? Who is going to churn and who is not going to churn unless we apply? It's a very good question. But before I apply the model, I should know who is going to churn. See, now the thing is, let me answer this. If I don't know who is going to churn, and I know one of the best uh, carrot in my hand, best thing that I can do to retain customer is to give them 5 GB of data free. If I give 5 GB of data free, I know many of the customers who are likely to churn, who churned, could have been retained. Assume.
Okay.
Should I go ahead and tell all my customers 5 GB free?
No. No. Only the 15%.
No. Only the customers who are likely to churn to whom I should be giving this offer. Right? So the objective of the model is to identify who is likely to churn. Once you know who is likely to churn, before they are churned. Now because February data I'm going to use to predict March. Once I am using February data, I know who is going to churn in March. Is the March month completed? No. March is ongoing, which means those who want to churn will churn in March. But can I take some retention strategy?
Yes.
In this case, 5 GB data free.
Okay.
If I can take this retention strategy, I send them all SMS and I call them saying, sir, this month we are giving you a 5 GB data. Will they churn?
No.
Many of them will not churn. Right?
Yeah.
I have been able to retain.
But this variable depends only on data usage. There are many oldies who don't use data at all. That is one area.
Now the question being asked is that this model is based only on the data usage. The answer to this is there are many other behavioral variables which we are going to create.
Yes.
The model will be a function of many of those behavioral variables. Just to explain, because I was not getting the confidence that there is an observation window, there is a prediction window, and then when you have a model, you use it on an ongoing basis. That's why I reduced my model to a multivariate, from a multivariate model, multiple variable regression model, I'm converted into a single variable model to highlight the fact that once you have got a trend and once you make a single variable model, you can use that model on subsequent month to predict who is going to attrite. This model could have come from 10 variables.
Okay. One question.
Yeah.
Okay. Now, like if suppose the Reliance has not been launched now, and in the next month it's gonna launch, and like the Vodafone users who are using a very high data, like is
Let us now understand the concept of test and control. Let us understand the concept of test and control. See, once you have built a model, assume now you have built a model by which you are able to predict who is likely to churn and who is not likely to churn. So what you are doing is what you are now using that model equation or that model rules on February end data. Applying that model rules, you would have now assigned a score to all the customers, and you would have given them probability of churning. Some you would have said high probability to churn, some you would have said low probability to churn. And what you are now going to do is you are going to target the high probability customers with some offers to retain them, and you do the campaign. Give some offers to retain them. You find that the customers whom you gave campaign, they have not churned much, and the set of other customers to whom you did not give campaign, they have also not churned much. Initially your churn expectation was 15% in your high propensity churn bucket and 1% in the lowest propensity. Now because of your offer, that 15% has come down to assume 3%. Is that 3% because of your campaign?
No. No.
Then why that 15 got down to 3%?
No.
The high that you estimated on the model, based upon model you have created buckets. One of the bucket is 15%.
Okay.
In that bucket you are now sending offers.
Okay.
And because you are sending offers, in that bucket you observe only 3% of customers have churned. Is that because of your model?
Yes.
How do you know it is because of the model?
Customer is accepting the offers.
But you are sending to everyone.
No, we are sending only
That 15% segment. You are sending everyone who is in that top segment where 15% churn is there.
Right.
You are marketing and giving it to everyone.
Everyone as in like all the
In that bucket. In that bucket, everyone.
Okay.
Everyone in that bucket.
So our expectation is like 0 churn.
No. Now when you are targeting everyone in that bucket,
Right.
you are seeing a churn rate of 3%.
Okay. So it has reduced from 15 to 3. It is a good sign.
It is quite possible. It is quite possible. No, it is quite possible that the scenario in market changed and the offers of one of the competitor who came saying that I'll give you very best offer which is 20% tariff lower than anyone else or 20% data higher than anyone else. He did not come up with that kind of offer and he charged higher. And many customers who thought of moving did not move. Can that be reason?
Yes.
Okay. So that is external scenarios are possible, which could also have caused this 15 to become 3%. Agreed? Do you agree or not? There can be external scenarios also that in that given month there has been some external scenario because of which customers did not churn as which was you were seeing in past. So what we typically do whenever these campaigns are sent, we will not be sending this offer to everyone. A small set of customers, a 5% of that segment, say there were 1 million customers who are in a bucket where we expect 15% churn. From that 1 million customers, I'll take out 5%, which is 50,000, which is a sizable base. And to remaining 9,50,000 customers, I'm going to give the offer. Now what will happen is in 950,000 customers whom I give the offer, the churn will come down to 3. But in this 50,000, probably the churn is 8%. The difference between 8 and 3 is because of the offer. And this 50,000 to whom I don't send the offer, despite knowing that they are going to be churners, is called the control group. This is the concept of test and control. This is the concept of a test and control. The base which you do not target and you keep it aside to know what is the baseline. Because when you do campaign, there has a campaign impact. So the campaign impact cannot be considered baseline. So to whom you do not do anything is called baseline. For example, many banks, what they do in the beginning of the financial year, say many of the banks today have got 8-10 crores customers, right? SBI has got 25 crore customers after all the 5 state banks will merge with SBI. So many banks, what they do in beginning of the financial year, they take a small segment outside, and to that segment they decide they are not going to run any marketing campaign in next 6 months or in one full financial year. Now this is a segment to whom they are not going to give home loan, personal loan, car loan, which means they will extend the loan, but they are not going to send an offer. Are you getting? They're not going to send a communication, we are having a home loan, we are having a car loan. This base they are going to keep aside. During the year, they will keep doing campaign to remaining base. End of the year, they will see this 50,000, this 5%, we did not proactively reach out. What percentage of customer took home loan? What percentage of customers took term deposits? What percentage of customers did investments? The remaining base, they gave offers. What percentage of them did home loan? What percentage took term deposit? If the gap is there, I can clearly say my campaigns are delivering value. If the gap is not there, my campaign is not effective. To be able to assess how good your campaign is, a base is kept aside, and that is called as control group. And the base which you target based upon your model or your business rules, whatever you are doing, is called test. Is the point clear? Without control, you do not know what is the baseline. Without control, you do not know what is the normal condition behavior. Without control, you do not have a way to compare the results. As such, whenever you do a campaign, you should always have a control group. Is this point very clear? Shailesh, Parul? Yeah? Okay. Any ratio of control base? Yeah, Parul, it is a random base. And what should be the ratio? Typically 5%, 10%. If the base is too small, then even 20%. For example, if I have got only 100,000 customers.
If it is like, suppose in an area, if it's like 100 district.
Yeah.
So, like in that particular one.
Random sample. If I got only 100,000 customers, then probably I may have to give 20%. By 5%, 5,000 may be too small. Okay. If my base is too big, as I said, 10 crores, many of the banks has. In 10 crores, I don't want to keep 1 crore outside. I don't want 1 crore customers to lose out on my offers. 1% will be good enough. 2% would be good enough. I don't want 1 crore, right? But why? No, what is the question, Ritika?
She didn't get it out. Why?
No, see, Ritika, this is why we don't send campaign to control. See, that is one strategy. As I mentioned, some banks follow that strategy. Sometimes you may want to follow a strategy only at a campaign specific strategy. That this campaign I'm not going to send. Other campaigns I'll let you go. That is a campaign specific test and control. So you can have a test and control at an organization level. You can have a test and control at a specific campaign level. Also, a specific campaign, you will keep a control. That is also possible. It all depends upon your design. And the reason why, Ritika, we keep a control and don't send the campaign is, yes, and this is what is used for net uplift modeling. And Ritika, why we don't send a campaign? Because if we don't send a campaign to a control group, that becomes my baseline. If you see this, this control group, it becomes a comparison, no changes, normal condition. The test group is basically, I am testing the model. One variable thing tested. That is the model in this case. Okay. If things are not very clear, let's take this example. The graph, the tree pots, the pots you see in group A and group B. Group A is a control group. Group B is my experimental group. The treatment that I am giving to a group A is I am giving some plain water twice a week for 3 weeks. I am testing a fertilizer solution to see whether the fertilizer increases the productivity. To the group B, I give fertilizers twice a week for 3 weeks. The quantity is same, 200 ml. I see in the group A the tree grows 18 centimeters. In the group B the tree grows 32 centimeters. Just imagine, just for the time being imagine that the group A is not available. If the group A is not available, what would have happened? This is not available. You are now just giving fertilizer. Can you make any statement that the fertilizer has increased productivity? You cannot say fertilizer has increased productivity. To be able to make these kind of statements, you require a control group. And that's why the concept of test and control. One more final concept before I complete these analytical concepts, A/B testing. A/B testing is not same as test and control. Let me be very upfront. But many people get confused that A/B testing is same as test and control. What is A/B testing? For example, and this is what I am now doing quite often. When I do a Facebook marketing for my training program, what I have done is I've got 3 creatives. And I have put those 3 creatives on the Facebook. So randomly when the campaign gets shown to some customers, some users on Facebook, ad 1 is shown, to some ad 2 is shown, to some ad 3 is shown. Now depending upon what message I have given in ad 1, 2 or 3, I get higher response in certain ads and I get poor response in certain ads. Does it not tell me that probably your communication in ad 3, where I get high response, is better off than the message that you have given in ad 1? And this is called A/B testing, when you test different versions of our offer or design and randomly give those offers designs to consumers. And when you do it randomly, the overall behavior can be considered as a judgment on your offer acceptability or not acceptability. The offer which does best, what you are going to do is you are going to say that going forward I'll keep this design only, I'll reject my other designs. And that is called A/B testing. A/B testing is also sometimes called champion challenger. Okay, where there is one is a champion, the other becomes a challenger. So if I have got a one, say assume I already have a predictive model, and tomorrow someone else comes up with more domain knowledge and says that, hey, your model I can do better than your model, and he builds another model. So what I'm going to do is I'm going to run campaign to some segment randomly based on my model, and the other person is going to run campaigns based on his model to another random segment, and then we are going to test. It becomes a champion challenger. Yeah. So that kind of things is called A/B testing. Limitations: A/B testing can't isolate which variable drive customers to act. This is a limitation, and as such it just tells which of the two is better. That is one. Now second is somewhere Parul mentioned net uplift modeling. Let me highlight what is net uplift modeling. So when we are doing some campaigns for marketing, what we do is we send offers to consumers. Now let us take this example of churn itself. Okay. In churn, we have been able to identify customers who are likely to churn. And to those customers, we are going to send an offer to retain them. There is another set of customers who are not likely to churn. To them, we are not sending. Is it possible that of the customers who are likely to churn, can I identify customers who are going to churn irrespective of whether I give them offer or not? See, when we had a 15% churn rate and I said the churn rate comes down to 3%, which means certain customers are still churning despite offer being given. So what it means is if I know there are certain customers who are going to churn, it is possible to further identify the customers who are going to churn irrespective of whether I'm going to give offer or not. And that identification is possible from net uplift modeling. Let me take this net uplift modeling from a marketing standpoint rather than from a churn point where I want to sell a product. Say I am a bank and I want to sell personal loan. Is personal loan a product where there is a need? Customers take personal loan when there is a need. Do you agree?
Yes.
Yes. Customers take personal loan when there is a yes. Usually they take. There are some customers who do not wish to take loan, but there is a need.
Okay.
There is a need, but they do not wish to take loan because they feel the interest rate is higher. If I give them a lower interest rate, will they take?
Possible.
Possible. So what I can say is there are two types of customers. One type of customer is who don't need a personal loan, and there is second type of customer who needs a personal loan. Now within the customers who need a personal loan, there are two types of customers. One who will take the personal loan irrespective of interest rate because there is a high need. And the other is who needs loan but is trying to avoid it because he feels interest rate is high or probably he can live without that for some more time and he's trying to prolong it. When we build a response model, a normal response model typically helps you identify who needs a loan and who don't need a loan. And when this kind of a model is built, typically what happens is you end up identifying those who need a loan and also those who are in need but are wanting to prolong. Now someone needs a loan and you give him an offer that I'm giving personal loan at 10%. But if you would not have given offer, that customer would have himself come and took the loan from your branch at 12%. In that case, are you losing on opportunity?
Yes.
So by targeting a customer who needs a loan and despite knowing that he needs it and giving a low offer, you're losing on the opportunity. Is there a way to differentiate the people who need a loan and will take it irrespective of whether you give offer or not, and find out the customers who will take it only if you give an offer? It is possible using logistic regression technique itself but by bringing additional attributes, whether loan taken based on offer or not, whether campaign was done or not. And that technique is called net uplift modeling. Even net uplift modeling requires a knowledge of logistic regression technique. Okay. So this is the basics on analytics concepts before we move to logistic regression. Is there any questions? Let me quickly slide through the skim through the slides. Analytics, predictive analytics. We'll check that, Parul. We'll see how if it's possible. Then supervised, unsupervised learning, and logistic regression is a technique which is used in supervised learning, is a part of supervised learning technique. Various examples where logistic regression technique can be used: HR attrition, employee churn, telecom churn, retail churn, win back, banking cross-sell, upsell, risk modeling, insurance, modeling terminologies, business objectives. First step is converting a business objective to a modeling objective, defining the target, pinpointedly defining the target definition. Possible outcomes is positive, negative, indeterminate. Indeterminates to be removed if there are any. Dependent variables, independent variables. Hypothesis testing, hypothesis creation, modeling based, development validation, holdout, window definitions, observation window, prediction window, test and control. This is test and control is from an implementation point of a model. Without test and control, you cannot compare whether the model and campaign is performing, not performing. A/B testing. These are the concepts that we have covered. Now we will move to logistic regression. Before we move to logistic regression, let us take a quick 10 minutes break. So now with the analytics concepts we have seen, now let us move to a logistic regression technique. We are going to understand what is logistic regression, and as we understand, we will parallelly build the logistic regression model using R. Okay. Some of the concepts that are important for one to know in logistic regression is what is natural log and what is exponential. These two important things we have to understand. What is E? E is basically a mathematical constant that is the base of natural logarithm, and its value has been found to be equal to 2.71828. How has this been value found? If you go to this Wikipedia site, I've shared multiple links as pre-reads. I hope you people have done those pre-reads. Multiple scientists, mathematicians, they have done multiple experimentation, and through multiple experimentation they have reached this number. One of this is basically an infinite series of n factorial, 1 upon n factorial, which is being shown here. If we do this calculation, the limit n tends to infinity. If we keep doing summation of it, limit n tends from 0 to infinity, summation of 1 divided by n. This value reaches a constant, and that constant is 2.718. That value is 2.718. Okay. Similarly, it has been found that if you do interest, for example, if you do interest calculation, for example, we typically get interest annually. Sometimes we may get interest in our bank account semi-annually. Probably we may get interest quarterly. Probably interest may be paid monthly. This can be reduced to weekly.
Day wise.
Can it be reduced to daily? It can be reduced to daily. Can it be further reduced to hourly? It can be reduced to hourly. Can it be reduced to minute, seconds? Can it be reduced to limit t tends to 0? And if you do that, which means you are doing a continuous compounding, limit t tends to 0, again it has been found out this calculation of compounding interest will go to a formula e raised to rx. Again the exponential constant comes into play. Okay, so there are various ways by which mathematicians have come and they have reached a conclusion that this E, which is a mathematical constant, there is some constant number observed in various scenarios, and it's also called Euler's constant and so forth. So first is this number E. Okay, the function Ex, when we typically write this kind of a thing, the function e raised to x, we define it as a exponential function. Okay. Now let's see natural logarithm. There is a relationship between exponential and log. Again, I have shared this Wikipedia site, but let us do it some practical mathematics. Say there is a number 10 is equal to ln of 10. Okay, it comes to be 2.30. This is my number. This is ln. Now what is the relationship between exponential and logarithmic? Say if I have got something ln of x, and this ln of x is equal to y. What it means is x is equal to exponential of y. This relationship, okay? Mathematics, this mathematics everyone know? If yes, then I can move forward, because this is one relationship that we need to know. Yes. Yes. Okay. So there is a relationship between log and exponential. Y is equal to log x. X is equal to exponential of y. Okay. So let me not go into the derivation and other calculation of it. Now, logistic regression. These are the two terms, because when we are building this logistic regression, why I wanted to explain is this ln p upon 1 minus p is equal to this. This equation is like y. Y is equal to a plus bx. Yeah. So when I have this equation, if I want to solve this equation, then exponential and log relationship will come into play. That's the reason I wanted to ensure that those concepts are clear. Now before I move into all those things, let me explain logistic regression. Application of logistic regression. Logistic regression is used in scenarios where your target variable has value between 0 and 1. When your target variable has value between 0 and 1. When you are trying to predict the probability between 0 and 1, you will make use of a logistic regression. Can I use a linear regression instead of logistic regression? Can I use a linear regression instead of logistic regression? No. Reason being, when you have a linear regression, you can use linear regression, but technically no. If you put some caveats, then yes, but technically no, because linear regression is not bounded by 0 and 1. What is the range of a linear regression? Minus infinity to plus infinity. If I develop a linear equation, the value of y, depending upon the value of x, it can range from minus infinity to plus infinity. But what is the range of probability? 0 and 1. If I want probability prediction and where the range is between 0 and 1, I cannot use linear regression. In that case, I want to transform the model such that my range is bounded between 0 and 1. Let us take this with some practical examples. This is my data set. I have given you a development sample. In this development sample, what we have done, what this data is all about, a bank had executed a campaign to sell personal loans. And they gave an offer saying that if you take the loan, you will be marked as 1. And if you don't take the loan, then those customers are marked as 0. So after the campaign, some customers took the product, personal loan, they were marked as 1. Those who did not take the product, they are marked as 0. Now we are trying to build a model which will help us predict. If we use the model going forward, we are going to predict using the model who is likely to be loan taker and who is not likely to be a loan taker. For that, I have got certain demographic variables: age, gender, balance. Age, gender, occupation are demographics, and certain behavioral variables, which is balance, number of credit transactions, age, score, holding period. These are certain data points which are available with me. Target is my y. Target is my y because I'm trying to predict target. That will become my. And with y, I'm trying to now going to establish relationship between all of them. For the time being, let us assume we are trying to establish relationship between target and say number of credit transactions. I want to build a relationship between this and this. Okay. So what we'll do is we'll build a linear relationship. To build a linear relationship, what I can do is, just 1 minute, I'll take this column and I'll take this column. Let me plot a scatter diagram. Home, where is scatter diagrams? Draw, no, insert, picture, yeah. Let me draw a scatter diagram. This is the kind of graph I get. This is 0 and 1 because 1 is my y and this is my number of credit transaction is my x. Let me change the axis. Format chart, select data. let me change this is horizontal x-axis, switch row and column. Okay, or probably I'll have to select this data. I'll make a copy of it. Control V. This is how let me select it, because it is not allowing me to switch that on the graph. Insert, scatter. This is the right graph. The old graph is wrong. Why? X-axis should be independent variable. Y-axis should be dependent variable. This is my scatter graph. I want to assume I want to build a relationship between these two. If I take a linear relationship, I can have a add trend line, and in trend line I'll say linear. Okay, I'm saying I want to build a linear regression and display equation, display r squared, set intercept, whatever. I'll not say set intercept. Okay, so I got this linear relationship. This is the equation which I am getting for this model. Okay, why is it not allowing me to increase the font size? Okay, I'm not able to increase the font size. No, probably it will be here. Yeah, I got it. So this is my equation, linear equation. I hope all of you are with me. What I have done is, with target and number of credit transaction, I've got the linear equation. So my equation is 0.0029 times x, that is number of credit transaction, plus 0.04. With that I can predict the value of y. So if I apply that, where's that chart gone? Sorry, this is the chart. So the equation is y is equal to 0.0029x plus 0.04. This is the kind of a linear equation I get. Now if I want to predict the y, there is a target, my prediction would happen like this, is equal to 0.0029 multiply x is what? Number of credit transactions, plus the intercept 0.04. So what will happen? This is the kind of prediction I'll get. So this is the prediction I'll get. Let us see if all values are between 0 and 1. Fortunately, it may so happen that all values are in between 0 and 1, but still there may be some cases for which it may not come between 0 and 1. So 0.0000. Okay, here fortunately all of them are 1. But assume this value, number of credit transaction, assume it is quite big. Say 1000. Just assume for the sake of argument. For the sake of argument, it is quite big. In that case, what is possible is, with this linear equation, my value of y can go beyond 1 also. In that case, my probability estimate in this case would be 2.94. In this kind of a scenario, what you are going to do, if you are using linear regression to predict, then you will put a caveat saying if value greater than 1, then 1. If value less than 0, then 0. That is the caveat. You can still use a linear regression. is it possible that I have a modeling technique? Is it possible that I can have a modeling technique by which I do not have to do these kind of caveats? If greater than this, if less than this, can I have a technique by which the value is restricted between 0 and 1? No, not capping. So here what logistic regression says is, instead of modeling for this equation, and frankly speaking, how does this linear regression can be built? Probably let us do that also. Because if you see this kind of a data, visualizing that having a linear equation from this is not possible. So in the background, lots of other things would have happened. What would have happened in the background? Let me show it. I'm trying to mimic it. Okay. Insert pivot table. Now, and again, the problem with that linear equation, no, sorry. This one is number of credit transaction and target. From the given data, what I have done is I've created a summarized data point. Yeah. From the given data, I'm creating a summarized data. So this is number of credit transactions, count of 0, how many zeros are there, count of 1, count total. These are the values. I'll just copy paste. And this is my target rate, or I can say probability. So here in segment, which is number of credit transactions 0, what is my target rate? What is my success rate? It is not 100%. It is 16 divided by 437. I hope all of you are with me. When we model for an event which is responders, I want to compute what is my response rate. The customers who convert are marked as 1. The customers who don't convert are marked as 0. The data is about a campaign done by a bank to sell personal loans. Some of them took, some of them did not take. Those who took are marked as 1. Those who did not take are marked as 0. Now, in the set of customers who has got 0 transactions, and I have given you demographic variables, I have given you some behavioral variables. In the segment where the customers have 0 transactions, how many customers have taken personal loans? 16 customers have taken. How many customers are there in that? 437. So what is the response in segment which is 0? It is 16 divided by 437. Likewise, can I compute the response rate? Okay. All of you with me? Frankly, I want to build this linear relationship between this and that, because the previous one was having just 2 categories. Actually, in the background, regression is doing all of this, and it will give weightage to how many observations are there and then build the model. But this is what we are trying to establish. Let me now put a scatter diagram for this. This is actually a scatter diagram for number of credit transaction versus response rate. Yeah, if I now put a scatter diagram, you will get the things much more clear. I want to put a linear regression. This is the kind of trend. Okay. Now here with this equation, if I take this equation, probably definitely what will happen, I'll have a upper bound and lower bound which will go above 1 also. So what the statisticians who developed this logistic model said that we are now trying to build a equation y is equal to alpha plus beta 1x, which is this equation. Y is equal to 0.0028x. Let me take this, copy this. This is my y. And with this y, if I do the calculation, 0.0028 multiply plus 0.0473. Okay. This is the model that we have got. And the problem is if this n goes very high, this can go above 1. That is 200% also. This is what we did earlier also. This is what I tried to show. To overcome this problem, instead of modeling y directly, which is response rate directly, can I do something else? What that can be? I am trying to here first model probability P. I can do a model where instead of modeling for probability, I'll model for odds. Instead of modeling for probability, I'll model for odds. What is odds? Let us understand what is odds. Probability of an event occurring divided by probability of event not occurring. That is called odds. Okay. What is the probability of event occurring here? 3.7. Probability of event not occurring? Typically, probability of event occurring is represented by P and probability of event not occurring is represented by Q. P, Q. So what is the probability of event not occurring?
Target rate minus
1 minus target rate. Because probability of event occurring is 3.7, then probability of event not occurring is 1 minus 3.7. So equal to 1 minus P. So in that case, this is my probability. So I can do 1 minus that everywhere. And that is what the probabilities I'll get. Odds. What is odds? Odds means ratio of probability of event occurring divided by probability of event not occurring. That's the odds. So P divided by Q is called odds. So I can have this. Let me convert this as numbers. Okay. So I can compute this odds. What does odds show? If you see the odds number, odds of conversion to non-conversion is 0.04. What it means simply is 4 out of every 100, no, not 4 out of every 100, 4 from 100, 4 will convert and 96 is not going to convert approximately. Okay, so this is the odds. This is how the odds keeps changing now. I could have built a model using odds as my y instead of probability directly. The problem with using probability directly when building a linear model is range is not bounded to 0 and 1. So the first transformation I am trying, instead of building a model of probability versus the independent variables, I am now trying to model odds versus the independent variable. Similarly, if I build this model, I'll again run into the same problem, which means I'll get a linear equation, and that linear equation, when I solve, the values of probability can go above 1. So the next transformation that the statistician did is log odds. Okay, log odds. So what I'll do is I'll do a log odds of this odds. When you do this log odds, now you build a model of this. Let me delete this. It is probably disturbing me. Now when I build model of this log odds, ln odds, let me write it like this. With respect to this, I'll get an equation. Okay. What that equation will be, log of odds is equal to beta 0 plus beta 1 x1. This error term is not to be considered. This is the model that I'm now building, is equal to beta 0 plus beta 1 x. X in our case is number of credit transactions. Okay. I'll build a relationship between this and this. Let me introduce one empty slide. Ln P divided by 1 minus P divided by 1 minus P is equal to alpha A plus beta B dot X. This is my equation. This equation is like a linear equation. This part is like a linear equation. Only thing, instead of modeling Y directly, I am transforming that Y and saying this is equal to this equal to this. So instead of modeling for response rate, that is target rate, that is probability of response, in logistic regression, if I would have modeled directly this way, probability is equal to A plus Bx, we see the range is not between 0 and 1. So we made a change and we said we'll model for ln P divided by 1 minus P equal to Y equal to A plus Bx. So I can say this A plus Bx, whatever is the regression model I get, is equal to Y. If this is equal to Y, if I remove log from left hand side and move it to the right hand side, what will it happen? This equation will become P divided by 1 minus P is equal to, if log on the left hand side is moved to the right hand side, what will happen? What is the relationship between log and exponential, this will become, right? Now if 1 minus p, which is in the denominator, is moved on the right hand side, what will happen? P is equal to 1 minus p multiply exponential y. If I move minus p, which is on the right hand side, to the left hand side, what will happen? P plus p multiply exponential of y is equal to exponential of y. Agreed? P on the left hand side is common, so I can say p 1 plus exponential of y is equal to exponential of y. I can now take 1 plus exponential y on the denominator on the right hand side. P is equal to exponential y divided by 1 plus exponential y. Yes, this I can say is equal to 1 divided by 1 plus exponential of minus y. Can I say that? What I'm doing is I'm dividing this by exponential y, I'm dividing this by exponential y, this by exponential y. This exponential y divided by exponential y will become 1. This is 1 here. This numerator exponential y divided by exponential y is 1, which is in the numerator 1. This 1 divided by exponential y, 1 upon x is equal to x raised to minus 1. So this becomes exponential minus y. This is my formula. And this y is what? What is this y? We started this y as a plus b dot x format. So this p, can be now written as is equal to 1 divided by 1 plus exponential of or minus. So now I can say exponential of minus bracket a plus b dot x. Brackets are proper? Yeah. So what is happening is actually we are building a linear model only. We are building a plus bx only. But instead of saying y is equal to a plus bx and instead of saying direct y is probability, instead of taking y as probability, we are taking ln p upon 1 minus p. And then solving this equation and getting this value. What is the advantage of doing all of this? Now let's take this equation in Excel. Let us take this equation in Excel. This is the equation that I had typed there. So I'll have y and I'll have p. Let me take some values of y. What is the corresponding values of probability we get? Is equal to 1 divided by 1 plus minus this number 0.73, 0.88, 0.95. As I keep increasing this number, this value goes up to 1 only. Can you see?
Yes.
I am keep increasing this number. It's not going above 1.
So like if you make it to 0,
This one 0, 0.5, minus 100, e raised to minus 44. It's still not 0. It has gone to e raised to minus 40. It is still not gone to 0. What it is showing you is by doing all these transformations, instead of modeling directly for probability, if we are modeling for log of odds and then building a linear equation and then solving that linear equation and then reconverting log of odds is equal to y and then saying p is equal to 1 upon 1 plus exponential minus y for any given value of y now evaluated, p will be between 0 and 1 only. And this is what we want in logistic regression. This is not logistic regression. This is what we want when we are trying to predict the probability. Because our objective was to predict the probability of each customer. To predict the probability of each customer, we require some model. What is that model? I don't know. So first of all, I tried out building a linear model. In a linear model, the relationship is what? Basically, this is what is happening. Probability is getting computed, and in the background, probability as a relationship of number of credit transaction is getting evaluated. And this probability is getting weighted. The weightage is there of how many observations are there also. Because when the linear regression will happen, it will give how many observations are there in this probability bucket, in this thing. So all those things are happening, but the problem with this is for some value of x, my probability can, predicted probability can go above 1 also. Yeah? But if I change this, instead of modeling the target rate, this P directly, and rather than modeling that, I model a log odds, build an equation, and then I get some y value, and then I put that y value to in a reverse form, where that is 1 upon 1 plus exponential minus 1, and then compute probability. My probability range does not go below 0 and above 1. This is the reason we use logistic regression when we want to estimate probabilities, and logistic regression is nothing but a transformed linear regression. Logistic regression is nothing but a transformed linear regression. Sriram, specifically from you, I want to know if it is understood. Sriram? Sriram, are you there? Shailesh, are you there? Shailesh, did you get? Because you are first time you are coming across this logistic regression. Are you able to get the concept? You can unmute yourself, Shailesh. Okay. Why do we say logistic regression has high bias that is not able to capture non-linearities even though we transform? So by now you would have understood that logistic regression is a modified version of linear regression. In linear regression, when we completed linear regression, what was the last slide that I showed? Homoscedasticity, heteroscedasticity. What is heteroscedasticity? Heteroscedasticity is simple. The variance of the error term is not same across all values of x, which means some values of x has less variance, some value has got higher variance for the error term. When there is linear regression is impacted by this model, which is heteroscedasticity. Logistic regression is nothing but a transformed linear regression, which means if there is a high variance in certain segment, that is, if there is a bias, logistic regression will not perform well for that biased data. It will underperform or it may overperform. And that is a problem of logistic regression. Jenny, no, did not get it? Okay. Now, in logistic regression, we are trying to build. What are we trying to build in logistic regression? We are trying to build a model of log p upon 1 minus p as a function of this independent variable x. So actually, I am building a log odds as a linear relationship with x.
Yes.
Agreed?
Okay.
If I am building a log odds as a linear relationship with x, this is what I have computed as a log odds.
Yes.
This is my, sorry, what was the value here? 0. So this is my data, and with this data, this is my log odds. I am now going to make a scatter plot. A scatter plot is this I got. Yeah? Wait. This is a scatter plot. This is basically, this axis is now log odds. And this axis is my x-axis. That is number of credit transaction. For this, I am now going to build a linear equation. Let me build a linear equation. So which means as good as I am saying add trend line, linear, display equation. Okay. This is my linear equation. Yeah. Assume these data points are not scattered like this. These data points are not scattered like this. Let me make some tweaking in data points. Let me wait. Free space. Let me do free space. Data view. Free space. Okay. At least I know which header is where. When this data is what I got, so what I'm going to do is okay. This is equal to this plus this. And these probabilities are computed. Target rate is basically, ratio is already there. So let me now put something like this. Count of 1, 0, 100, 70, 10, 85, 80, 100. Assume numbers are like this, okay? Just I'm making changes. Okay, I'm just making changes myself. These are some numbers which I have now intentionally corrupted. Okay. Yeah. With the logistic regression, my prediction would have been here, but actual all of them are here. Why is this? Will my model prediction will be a right prediction? It will be way off for this data points.
Yes.
And from the data, they are nowhere outliers. They are nowhere outliers. Only thing is the behavior here of the response segment is biased in this segment. Because it is biased, my prediction and other data points, my data points is now because of this thing. Let me use many things. This is biased. I made this as biased. Because of this, my line has moved up.
Yes.
If you want to see this, let me try to nicely put a line on this top of it. This is the red line. Let us now, what we do is, in this scatter plot, select data, the data selection. Let us reduce these data points. "46" series is 46. It should end at 46. Okay. Can you see this line? It has moved, changed its space direction.
Yes.
What happened is because of those dotted dots, which were extremely high success rate, they were biased. And because of that bias, now can you see there these dots are coming up and down both sides? What is the impact of that? I'll again undo the graph. Can you see these dots?
Yes.
There is no dot which is above this line. What has happened is the prediction for them,
Was.
they have moved, all of these have moved below the line
Yes.
and all of these have moved above the line. The line is now trying to fit between both of them. But here it is not doing a good job. Neither is here it is doing a good job. Rest of the place till here, I can see dots on both sides. And this is what the impact of bias is. If there is a certain segment which behave extremely different, to adjust for their pattern, the model is disturbing the pattern of others also. Parul, I hope, do you get? I am trying to visually show things. See, Ritika, do logistic regression also follow that error term should be normally distributed? Theoretically, yes. Because logistic regression is nothing but a linear regression. Theoretically, yes. It should follow the same pattern as a linear regression, normal distribution. If heteroscedasticity is there, normal distribution is not there, then just now what we saw is going to happen. Parul, does it happen in practice? It happens in practice. And when we build a logistic regression, if we see this kind of a thing, if we see this kind of a pattern, I will build a separate model for this segment. I'll not build a same model for this segment with rest of the data. First, I'll split the data into two segments saying customers having number of credit transactions less than 40 or 42, greater than 42. Build one model for one segment, build another model for another segment. So to handle bias, we build multiple logistic regression models. Clear? Yeah? Let me erase all these inks. I hope the concept is clear. So simply put, logistic regression is a transformed linear regression. When we build a linear regression, there is no upper bound and there is no lower bound. Linear regression is bounded from minus infinity to infinity. Okay. If for the time being, if I would not have done that y is equal to log of odds, let us for the time being, for the sake, I'm doing all of this to make this concept very clear. If we would have said we are not building log of odds is equal to this, instead we say we are building odds as a function of the independent variables. What would have happened? Odds as a function of independent variables, it would mean that y is equal to p divided by 1 minus p, yes, is equal to a plus b dot x. I could have modeled this also. If instead of first attempt is probability, but the probability is minus infinity to infinity, because if I directly model probability, I would have got minus infinity to plus infinity. The second attempt I could have done is model for odds. Odds is p upon 1 minus p. Now let us see what would have happened if I model for p upon 1 minus p. So similarly, I can create this scenario y and then compute probability. So if I do that calculation, let me insert one blank slide. This slide is what we had, right? I am modeling this way. P divided by 1 minus P is equal to y is equal to a plus bx. I can say P divided by 1 minus P is equal to y. Right? P is equal to 1 minus P multiply y, which means P is equal to P plus 1 P plus P asterisk y is equal to y. Let me delete all of this. This is now creating clutter. So P is plus P asterisk y is equal to y. Yeah. P 1 plus y is equal to y. So P is equal to y divided by 1 plus y. Yeah. So this can be said as P is equal to 1, or we can have this only. P is equal to y upon 1 plus y. Okay. Let's keep it like this. So which means y and P is equal to y divided by 1 plus y. Let us put some values of y, minus 1, 0 and 1. If this is the case, what would have happened? Minus 1 divided by 1, I cannot say like this, is equal to y divided by 1 plus minus y. We'll have division by 0 problem. I cannot compute probability. There is a problem. Okay. But if I have this equation, minus 1, minus 100, I do anything, I'm able to solve. Let us now see what would have happened if it is 0 is equal to 0 divided by 1 plus 0. I'm okay. Yeah. If this goes to infinity, what will happen? This would be infinity divided by infinity. Yeah.
So again 0.
Infinity divided by infinity is undefined. Alright. If I make this as too large a number, what is happening? It's 1 only. So the thing is, even using odds would not have solved us the problem. That's why log odds is the only way by which I can restrict the value between 0 and 1. And that's the reason why when we are building a logistic regression model, the log odds concept is used for building the logistic regression model. And that's the reason why we get this equation, which is shown here. So let us, logistic regression is based on a linear relationship between the natural logarithm of the odds of an event. What is odds of an event? Probability of event occurring divided by 1 minus probability of event not occurring. So probability of occurrence divided by probability of non-occurrence, and a numerical independent variables. And the form of this relationship is given as L is equal to ln O equal to ln P upon 1 minus P is equal to beta 0 plus beta 1 x. That error term is to be ignored. Y is a binary and represents the event of interest. Response coded as 0 or 1, failure or success. P is the proportion of successes. O is the odds of the event occurring. Odds is P upon 1 minus P. L is log odds. X is independent variable. Beta 0 and beta 1 are the y-intercepts and the slope respectively. E is the random error. This is a logistic regression. At a high level is the logistic regression concept done. Yeah. So if you have understood logistic regression, then basically we can then keep doing all of this. I think so we'll take a break here for today, because today I just wanted to cover the concepts of logistic regression. From a coming session, though we are half an hour early for the session, but now from the coming session we'll do execution of the logistic regression in R. Okay. By that time we'll start using R code, scripts, importing and other things. Any questions on logistic regression now? Parol, Ritika, Shriram?
Uh,
Yeah, Shriram, tell me.
is my understanding correct? Based on what we have seen, logistic regression will be applied when the data sets, when the variance in the data set is lost. Is that correct?
Logistic regression will be applied when our target is value is between 0 and 1. That point is clear, Shriram?
Okay.
That is one. Logistic regression typically is not able to handle bias. It does not handle bias easily. Now let us understand what is bias. Just give me a second. So coming to Shriram, your question on bias versus variance. See, error has got two components. Error has got two components. One component is called bias and second component is called variance. For example, this is an illustration. I have taken this person from this website where it has nicely explained what is bias and what is variance. Let us assume we are shooting a target through basically a gun, and all of these we are able to hit the target properly. In this case, I can say there is low variance and low bias because all the values are closer to expected mean. When the data is too spread out from the mean, we say there is more dispersion, and in that case we can say there is a high variance. Yeah, variance is how spread out the data is with respect to mean. In this case, you see that the data is too spread out, but it is not spread out only in one direction. There are certain points on the left hand side, there are certain points on the right hand side, there are certain points on top, there are certain points on the bottom, which means there is a variance but there is no bias. Now assume that the gun through which you are trying to shoot on the target board, you are seeing through that funnel and you are seeing through that pointer from which you are setting your target, but each time you do the proper setting, it does not hit the target, it hits the target slightly above the target. Your expected mean is here, but you are far off. But is there variance in this data? There is no variance, very low variance. There is but a bias. There is a bias. All your shots are hitting away from your target, but all of them are close to one point only, which means there is some problem, and that is called bias. And now this example here, all the dots are on one side only, which means there is a bias. Also the data points are scattered and there is variance also. This is the concept of bias and variance. Now let us use this concept in our data points. Let us take this linear regression or logistic regression, whatever regression you want to say. There is a X and there is a Y. Okay. Now here, these are my dots. These are my data points. Now the moment I go above a certain point, if I now build a linear regression, I'll get an equation which will go like this: straight line, though some crooked line has happened from my hand, but this will be a straight line. It would fit very nicely to points which are here, which are till here. It is going to fit nicely, but these points are biased. So my equation is not going to fit properly to them. And when this is the scenario, you have to use two linear equations. First linear equation for this part of the data, and second linear equation for this part of the data. If these dots would have not been like this, but you would have some dots here also. Then probably one linear equation would have done. Because for this part of the data, when you would have built model anyways, it would have fit in center only. Okay, which means there is not bias, but there is more variance. Now here the variance is more, but bias is not there. Earlier when I put all the dots on one side, which means there was bias. So this is the concept of bias and variance. And when there is a bias in data, typically what we see, we build multiple models. Let me give you example of bias. I'll take banking example again. As I always saying that I am slightly more conversant with banking. So I'll take a banking example. As a salaried customers, how many transactions we do in a month? As a salaried customers, we get one salary credit. We go 4 or 5 times in ATM, withdraw money. We write 3-4 checks, probably some NEFTs, EMIs, utility bill payments, all those things, either electronic payments or some check payments. In a month, we end up doing 10-11 debit transactions, and we end up having 1 or 2 credit transactions. One is salary and second maybe interest, or sometimes if there is some money we got, we put it. Now I see current account customers. How many transactions a current account person do? In a day, probably 3 or 4 transactions. Couple of checks they will issue to make payment to party. Couple of credits will happen because they will receive credit money from parties. In a month, they may end up doing anywhere between 100 to 200. Now I am building a loan cross-sell model. In that, I'm now merging business loan and personal loan both. I targeted all customers, current account or savings account, and said you want to take loan, come and take loan. Okay. Anyone who is responder, I mark it 1. Now I'm going to build one model for both the current account and the savings account, and one of the variable will be number of credit transactions. Will that variable be able to do justice? It will not, because that transaction volume will be high in case of current account customers vis-a-vis the savings account customers. That is one point. Second is that segment is more in need of money compared to a salaried guy. So they are more amenable to take a loan compared to a salaried guy. So because of that, it may so happen the transaction volume, if we try to now fit a linear equation, that is to the log odds versus number of credit transaction, we may not get a linear fit, a proper linear fit. After a certain point, it may require that if the number of transactions are increased beyond a threshold, you require a separate model. And that threshold, if you analyze who are the customers falling in high transaction, you will realize that it is current account. So you may end up saying, I should build a separate model for a savings account and a separate model for current account. What actually you are doing is, in a way you are saying that there is a bias in the transaction behavior. Current accounts have a high transaction behavior. whereas a savings account customers show low transaction behavior. As such, we should model them separately. And that's what is bias versus variance. Shriram, did I answer your question?
Yes, yeah.
Yeah.
So in the practical sense, we use all these
Yes.
equations or something to
Yes, very much.
predict, right? Okay.
Yes, we use all of this. Very much we use it, and there are lots of applications of it. Okay, so the question is, what are the downside of logistic regression and what is the plus of logistic regression? The downside of logistic regression is basically it cannot handle multicollinear variables. If there are correlated variables, then one of the of many correlated variables, only one of the correlated variables have to be kept. That is the limitation of linear regression also. When we built a linear regression, we saw annual income and monthly income multicollinearity, and because of multicollinearity, we have to drop one of the variables. So if I have multicollinear variables, a logistic regression will allow only one variable to be part of it. That is one major downside, because sometimes there is a slight different flavor in those multicollinear variables also. And specifically when we have many variables, we want to build many models, and some of these things can be taken care by techniques like random forest, neural networks, gradient boosting machine, which logistic will not be able to take care. That is one big downside. Second, as we already saw, bias data cannot be handled with one model. So we have to build multiple models, and manually we have to do it. The third limitation is it is too mechanical process. Each variable that we are going to bring in a logistic regression model, we have to closely observe the trend of that variable versus the log odds. And based upon the trend, we may then have to decide whether we require any variable transformation that has to be done. We'll see that those variable transformations in our subsequent sessions. That is the third biggest limitation. The biggest strength of logistic regression is it is able to measure the change in probability for every incremental change in value. For example, when we build that model, y is equal to log p upon 1 minus p is equal to alpha plus beta 1 x1. Okay, and then we said that p is equal to 1 upon 1 plus exponential of minus y. What this exponential minus y and beta, there is a relationship. What that beta of a variable is, we are slightly ahead of, this question is slightly ahead of the session, but what that beta of each variable indicates. If we do exponential beta, what it indicates for an incremental unit change in value of that parameter, how much is the odds going to change? Okay, and that gives you an indicator of if I'm going to increase it by 10 units, how much my probability is going to increase. It finally captures every unit change in the value of the x. As such, it gives you a very granular probability and a wide range of probability for your customers. That is the plus side of it. Any questions? Other questions? Okay. So with a high level overview, we'll end the today's session. Thank you.